Okay, here we go. 4-3. We're going to do 1 to 10 from the journal. I actually forgot to bring home my journal, so I'll be doing it on a blank piece of paper while looking at the Pearson online, just like I would expect you guys to do. The big thing to remember here is format, format, format. We're really building that foundation for really all mathematics. You're going to be solving equations for a very, very, very long time, building that house up. Today is the foundation, so it's really about format. Some of you guys are going to be good enough to really discover what the solution is without the format, but we want to pay attention to that format so that as we move forward, we know what we're doing. Number 1 says, how can you write and solve an addition or subtraction equation? So write and solve. I'm not going to get crazy about all of your answers. You could say you could use inverse operations. Oops, operations is spelled with only one P. You could use the properties of equality that we learned about in 4.2. And we could also substitute and solve. That's from 4.1. Anything you do here is probably okay. I saw some students saying, well, let me make one up. Y plus 10 equals 12. And then they would demonstrate that beautiful inverse operation of subtraction is the inverse of addition. Subtracting 10, the subtraction property of equality to both sides, drawing that line, crossing out the 0, isolating the variable, and getting your solution, doing that check step of that substitute and solve, taking your solution is 2 plus 10 equal to 12. 12 equals to 12, which is true. And that is a demonstration of how you would do it. So that's a great way to solve a math CR, is to actually do some math to talk about it. Number 2 says, explain how you can use the inverse relationship of addition and subtraction to solve the equation. N plus 7 equals 25. Well, frankly, I would probably do this with the math. So the inverse operation of addition is subtraction. And I'm going to subtract 7 because our goal here is to isolate the variable. The subtraction property of equality tells us what you do to one side, you must do to the other. Drawing that long line across, crossing out the 0 that I've created, isolating n on the left equals 25 minus 7. Brain not totally working today. I want to say that's 18. Doing that check step of is 18 plus 7 equal to 25. I am going to bring in my handy dandy calculator just to make sure that 18 plus 7 equals 25. Yes, it does. 25 equals 25. It is true. That means that 18 is my solution, and I'm going to circle it. Number 3. Claire had T books. After she bought 8 more books, she had 24 books. Write and solve an equation to find the number of books Claire started with. Claire had T books. She goes out and she buys 8 more books. After she's purchased those books, now she has 24 books. There's my equation. You could do 8 plus T or T plus 8. Now I'm going to solve it using our format. Right back here to the word format. Very important. We're going to isolate T, isolate the variable. Inverse operation is subtraction here because we're starting with addition. Cross off that 0. 24 minus 8 is 16. Is 16 plus 8 equal to 24? That is true. So T equals 16 is the correct solution. I'm going to come over here and do 4 right next door. Model with math. The outside temperature dropped 20 degrees Fahrenheit. Oh, wait a second. You know what I didn't do? Back up for a second. This needs a label. T equals 16. Books. Ooh, there was context in that problem and I missed it. -1 for Mrs. Roner. Label, 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 label. Anyway, back to number 4. The outside temperature dropped 20 degrees Fahrenheit from the time Ariana ate breakfast to the time she ate dinner. She ate dinner, the temperature was 35 degrees. Write and solve an equation to find the outside temperature. So T is the temperature we're starting with. It's going to drop 20 degrees so that when she sits down to dinner, it's 35 degrees. There's your equation. Inverse operation is going to be addition. So we're going to use the addition property of equality. What you do to one side, you do to the other. giving me T equals 55 degrees Fahrenheit. There's my label. Let me check it. Is 55 minus 20 equal to 35? 35 equals 35. It is true. There is my final answer. All right, let's go on to number 5. I actually think we did number 5 in class, but I'm going to do it again just so we see the format. In the textbook, it says to solve each equation. It is important to understand that when we are solving equations, our goal is always to isolate the variable. M is not all by itself here on the left-hand side. The inverse operation is to subtract 24. We want to really make 0 over here. What you do to one side, you do to the other. That's the subtraction property of equality. M equals 49 minus 24, 25. Is 24 plus 25 equal to 49? That is true. So M equals 25 is the solution. Number 6. 12 equals y minus 11. Now, many students get a little widgy here when we see the variable come to the right-hand side, but the process is still the same. We want to isolate y. Y is not by itself. It has subtraction by 11 here. We want to do that inverse operation. So I'm going to be adding 11, subtract 11, add 11. What you do to one side, you do to the other. That goes to 0, leaving me with y on the right-hand side and 23 on the left-hand side. So let's check it. Is 12 equal to 23 minus 11? I saw many students in class say 12 equals y minus 11. And they said, oh, well, you're subtracting 11, so y must equal 1. The good news is if you put that into your check step and say 12 equals 1 minus 11, 12 equals negative 10. What? That is false. That means that this cannot be the solution. So that's where that check step can really come in and help you. If you do something wrong, it's like pump the brakes. It's telling you you've done something incorrectly. Number 7, 22 equals 13 plus A. A is not isolated. We want to isolate A. We want A all by itself. We are going to, and this is addition by 13, so that inverse operation is subtraction by 13. The subtraction property of equality, what you do to one side, you do to the other. You draw that long equals line. Plus 13 minus 13 goes to 0, leaving me with just A all by itself on the right. 22 minus 13 is 9. A equals 9. Is 22 equal to 13 plus 9? That is true, so A equals 9 is my solution. 3 more. Number 8. T minus 40 equals 3. T needs to be isolated. T is not isolated. It's being subtracted by 40, so we're going to do that inverse operation, which is to add by that same number. Minus 40 plus 40 goes to 0, leaving me with plain old T equals 3 plus 40. Hopefully I don't need my calculator for that. Is 43 minus 40 equal to 3? That is my solution. Number 9. D plus 11. Now, most of us should be able to look at this and go, the solution is going to be 4. What I want you to do is practice that format. And really say, okay, remember, we're going to get into 2, 3, 4, 5-step problems. The format here is going to support that when we can't do it mentally. We're going to subtract by 11. That's that inverse operation. We're going to apply the subtraction property of equality by doing it to both sides of the equation. Got my 0. 15 minus 11 is 4. 4 plus 11 equals 15. True. That is my solution. It's okay to say, I know the solution is going to be 4, but then I want you to follow the format in order to do that. Last one, number 10. Scroll down my computer. 32 equals S minus 19. All right. We want to isolate that variable. We want to use inverse operations. So if I'm starting with subtraction, I'm going to use addition by that same number and addition by that same number. This is the addition property of equality. Draw that long equal line. Subtracting 19 and adding 19 gives me a 0, leaving me with S on the right-hand side. 51 equals S. Is 32 equal to 51 minus 19? I am going to pull out my calculator and say, is 51 minus 19 equal to 32? 32 equals 32. That is true. The solution is S equals 51. Keep using those check steps.